Hey there, more MedMath. So today we are going to review PO MedMath, injectables, PO, blah blah, safe dose, and then we're going to start into IVs and IV piggyback and how you think about those. So let's get started. Remember, you want to look at what you need and nothing else. So, a nurse is preparing to administer this medication 20, and available is tens. How many tablets? So you can see my answer's already in tablets. So desired over have. And if I need the quantity, I can. But I don't need quantity in tablets because they are just what they are. So I put my desired. What did the doctor order? 10, 20. So the 10 is on the bottom because that's what I have available. The order is for 20. I put that on top. Just want to make sure. 2 divided by 1, 20 divided by 10 would equal 2 tabs. Does that make sense? I look in my hand and I have one pill, it's 10, and one pill, it's 20. Yes, that makes sense. So I'm going to go ahead, check my answer, 2 tablets. So here I go. Here I go on my next one. They've ordered this medication, 150. Available is that same medication. All right. And then I double check. It's asking me for mils. So that's easy enough. My desired over have times my quantity. So what do they want me to give? 150. What do I have on hand? My 50. In what? 5 mils. Now technically, I could look at that and say 5 goes into 15 3 times. I can just do it all and put that math right in and not get confused at all. All right? But if I thought 5 went into 15 3 times, wouldn't I be giving 3 of these? So I'm going to consider my answer is going to be 15. But I go ahead and put this in my computer and figure it out. Blah, blah, blah. The other way that I can double check myself is if I know there's 50 and 5, what's in 1? 10. So then I can go ahead and say, okay, I'm giving 15 mils, and each one has 10 mils in it. Oh, it comes out to be the same answer, 150. So I have double checked myself multiple times. If I saw that this and this goes in 3 times, this goes in once, that would be 3 times 5, which would be 15. So I have checked this multiple times now. I feel confident I'm going to go ahead check my answer, and go give my liquid to my patient. So I got that done. Now, remember these. So this is asking me to administer amoxicillin 30 milligrams, blah, 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 who's 33 pounds. And I've got this available, and I'm probably going to need that because it's asking me for mils. And this is also asking me for mils. So now I kind of know where I need to go. Number one, what do I need to do? I need to make sure that it's in kilograms. So I'm going to go ahead and switch my kilograms. So let's just go ahead, grab our calculator. Oh goodness, where is my calculator? So I put in my 33 pounds divided by 2.2 makes it 15 kilograms. Number two, I say, hey, what's my recipe? So this is kilograms because I changed my pounds. And then I can take this and plug it into here. So let's just look at that. That was 30 times 15. And that 30 times 15 means that every kilogram is going to get 30 milligrams. And that's what it says. So I times that by 30, and I get 450. So I get 450. When I get 450, I ask myself, what was that again? 450 milligrams per day, because I didn't take care of the day yet. Okay, now, whether I want to do it now or do it later, it doesn't really matter. But this is divided equally every 12 hours. So that means into 2 doses. I could go ahead and half that right now. Then I come over here and I say desired over have times quantity. It's in 5. There's 200 in 5. How much was I giving? Because this is per dose. Per dose, my 450 divided by 2 is 225. So I'd put that there. $2.25. I could be using my 450 and then just divide it in half as well. If I did 450 divided by 200 times 5, I would get 11.25, and then I would divide that in half, and it would be 5.6. Okay, if I'm going to go with my 225, divide it by 200 times my 5, oh, I still get 5.6. Either way, if I use this and put that 450 down here, then I would divide it by 2, right? Either way, I'm going to end up with 11.2 per day and have to split that into 2 doses. So I could keep that big and then come back and say how many doses, or I can split it right then and there and go ahead and do the same thing. All right, so I've done it 2 ways. both ways gives me what I want. So let me go ahead and delete here. And I agree, it's 5.6 mils. Okay, here we go. Preparing to administer 250. And it is available. Oh my word. That's a lot of medicine, isn't it? So what do I need to do here? I want 250. And N5 is how much? Oh my goodness. 1, 2, 3. 3 grams is 3,000. So I take my 250 divided by 3,000 times 5, and I get 0.41. Depending on, 0.416666667. Okay, so depending on my answer, right, I want to look and find out if it says nearest tenth. If it says nearest tenth, then I'm going with 0.4. If it says nearest hundredth, then I can go ahead and put 0.42. Either way, let's go ahead and look at the answer. 0.4, because the 2 is not enough to make it the next number. Fabulous. Next. Okay, what does it matter what kind of med this is or what it's in? Milligram, milliliter, whatever, units, milliequivalents, whatever it is. I just want to make sure everything is the same when I set it up. Okay, so can I not go what's ordered? 3,000, 2, 3, and what is available? 5, 3, fabulous. 2, 3, in 1 mil. Isn't that the same thing, regardless if it says milligrams or anything else? So when I come over here, it's going to be 0.6. Does that make sense? I look back at this and I think, oh yeah, well, technically 0.5 mils, half of 5 would be 2,500. So yeah, it'd need to be just a little more than 0.5. So 0.6 makes sense. I asked myself, does that make sense? Fabulous. Okay, here we go. Oh, look, this is one of those safe dosage. And it's asking me to make the dose for this patient. So what does it matter? I'm going to do the same thing I always do. I'm going to get this into kilograms. Oh, darn it. They didn't do it for me. So I'm going to take my calculator. 95 pounds divided by 2.2. 43. You know, for my own sake, I like to leave those things on my calculator as long as I can, okay? So let's just leave that whole thing on our calculator. But if you were going to do anything, you would go right here and you would say 43.2. Close enough for government. Okay? Then where is my recipe? My recipe is right here. That's per dose, not per day. And it's saying 1 milligram per so I times it. Even though this looks like a divide sign, it really is a time sign. Per dose. So how many milligrams? This doesn't say that I'm pulling it out of a syringe or anything. It's just asking me what's the dose that I want to give. Could I not just say 43? For government purposes, close enough. We'll see what they want. Oh, nearest tenth. Oh, darn. Always read what they want, right? If they want nearest tenth, I go back out and I say 43.2. They probably want me to keep it as accurate as possible. And as accurate as possible, that 8 would make the 1 a 2, and it would be 43.2. Okie dokie. All right, here's one of those safe dosers. So what are we going to do here? Isn't it the same thing? So, first thing I like is that they put it in kilograms for me. That's good. And then here's my recipe range dose. Okay, so 1 kilograms. I love them. They did it for me. It's already done for me. 2, I say, what is my recipe? And I'm going to do this by 20. And then I'm going to come back by and do it by 25. So look at right here, milligrams per kilogram per day. Okay, times 20 kilograms times 20 kilograms. And that's going to give me in my 2-dose range, my high and my low. And this is going to tell me when I do this on my calculator. 25 times 2 is 500. So my dose range is 400 to 500 per day. Do I need to do anything else? Not really, because I got it. I got enough information, right? Now I just need to say, okay, what would I be giving per day? Okay, so I leave it in that per day, all right? And they want me to give 100 every 8 hours. 100 every 8 hours. So if I said how many of these, how many 8s in 24? 3. So 100, 200, 300. They want me to give 300 per day. Hold on. No, 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 no. They said that the normal would be 400 to 500. So what am I doing if I go give this? I'm underdosing the kid, right? So now this is an ABCD, so I'm going to go ahead and go through my true or false, and I'm looking for the true. The nurse administered the prescribed dosage. No, I don't want to. B, the nurse determines the prescription is above the recommended dose range. No, it's below. The nurse contacts the pharmacist to adjust the prescribed dose. Wait, who ordered it? D, the nurse determines the prescription is insufficient to achieve the desired effect. What is amoxicillin? It's an antibiotic. What if I gave this? If I gave it, they'd still be sick in a week. Or sicker, because we didn't have enough medication. So what am I going to do? The nurse determines the prescription is insufficient to achieve the desired effect and calls the doctor to revise the prescription. What am I going to talk to him about? I'm going to talk to him about, hey, can I increase that, sir? So if I know that it's supposed to be 400 to 500, if he wants to keep that every 8 hours, what am I going to do? So let's say 400 divided by 3 would be 133. 500 divided by 3 would be 166. So he could increase that to 150 every 8 hours. That's a choice. He has to determine what he wants to do here. Okay? Depending on the drug's action, he can either increase the amount of milligrams every 8 hours or decrease the timing and say like every 6. 100 every 6 would give us 400. 125 Q6 would give us 500. That's up to him. That's not my job. I don't get paid for that, right? All right, so then we get started on IV piggybacks. Yeehaw. So what is an IV piggyback? So an IV piggyback is this little bag here. You can see that this is a Practi vancomycin. So it's a practice vancomycin bag. What is all this about? Well, this is an antibiotic. And every once in a while, you know how you have this big bag of fluid running? This is called the primary fluid. Well, every once in a while, a nurse will go in the room and hang this little one. And this little one is a piggyback rider. So it piggybacks into my mainline fluid tubing to get to the patient. As long as these two IV fluids are compatible, we're happy. I don't need to have a pump, but I can have a pump. Okay? So either way, if I put it on a pump, it's going to be in mils per hour. If I free flow it in to the fluid, it's going to be in drops per minute. So when I'm doing this, all I need to think about is the volume over the time, okay? If I think about IV piggybacks or IVs, most of the time, all I need to look at is the volume of fluid, which is denoted as milliliters, over the amount of time they want me to put it in. Okay? Now, if that time is less than 60 minutes, they're trying to trick me, but I won't let them. If this would be like 15 minutes, That's less than an hour, right? So then I would just times it all by 60 to turn it into an hour, okay, to put on my pump. So let's work through a couple of those. So when I look at this bag, I look for how much volume is in it. I do not care what is in the bag. I do not care how many milligrams are in the bag. I don't care how many grams are in the bag. All I want to know is volume over how long do you want me to hang it. That's it. Okay? Now let's go forward and we'll talk about this. So, when my doctor wants me to give an antibiotic, and it's too long of a time to stand there and push it through their IV, I will get a little piggyback rider like this sent up to me, and I go in the patient's room, I spike it with tubing. The tubing piggybacks into my mainline fluid, and I open it up and let it go, and because of what the pump or the IV fluid is set at, it will go in an amount of time needed. Then, when I go back in the room, I can go ahead and shut that clamp because it's done infusing for the day. Okay? The next time it's due, I come in, I take down that old empty bag, and I spike the new bag and let it go in again, multiple times a day. But that means they are not paying me $40 an hour to sit at the bedside for 15, 30, 45 minutes to push this med. It's just an easier, more cost-effective way of getting that medication in the patient through their IV site without having to have a nurse sitting at the bedside. All right, let's look at what that looks like. Now, you know how those oral problems were? They love to confuse you, okay? Look how many words are in here. And you're like, oh my gosh, I don't even know where to start. Well, of course you don't, because you're not looking at just what you need. What did I say you care about? I said you care about volume over time. Okay? Volume over time. And this would be in minutes. If it's less than 15, I'm going to go ahead and multiply the whole thing by 60, which basically changes this number into whatever of an hour that would be running. Okay? So, when I look at this, the only thing I want to go find is the volume of fluid that this is in and the amount of time they want me to hang it over. Okay? So let's go. The nurse is preparing to administer. Don't care. Oops, there we go. 30 minutes. Don't care. Don't care. Volume. Hey, what is that? Don't care. Okay. Now, mils. And this makes it an hour. So my answer when I get it will be in mils per hour. Okay? Because I'm putting my minutes down here and I'm putting my volume up here. Okay? So let's go. They want 50 milliliters to disappear in 30 minutes. And I want to change that 30 minutes and into an hour because my pump runs on mils per hour. So now I've got it set up. I've got my mils, my minutes, and my hour. Okay? Fabulous. So I put that in my calculator, and it tells me I should be running that at 100 mils per hour. Okay, now, is anybody confused? Well, hold up. I only have 50 milliliters in that bag. I am aware you only have 50 milliliters in that bag. Remember what I said. It's to trick the pump to go faster because the pump only runs in hours. So you're tricking the pump so that that 50 mils is gone in 30 minutes. Because if you put it at 50 mils an hour on the pump, it would take a whole hour to get rid of that 50. And that's not what he asked for. He asked me to run that 50 in 30 minutes. Okay? If you think about an hour as a pie, and you cut that pie in half, and you say 30 minutes, yes. Technically, if I want 50 mils to go in 1/2 hour, technically, not that I'm going to, wouldn't I also be able to put another 50 in this half hour? So you are making the pump think that in the hour it's going to run 100 cc's of fluid. You don't have 100 cc's of fluid. So at the end of 30 minutes, this little bag will be empty and your big bag will start to flow again. Okay? So you are just tricking the pump that this one's gone. Now switch over here and it will continue to flow your regular fluid. It's a trick to make sure that the pump pumps it faster than what you could set it because the pump is running per hour. The pump doesn't run in minutes. Okay. It's just a trick. We're just making the pump run a little faster. Okay. So, think about this problem. Calculate the following IV piggyback infusion using a pump, mils per hour. All right. So what did we say we needed? We needed volume over time in minutes, because this is an IV piggyback again. And then times that all by 60 to change that in mils per hour. Okay. So now I go back, look at my problem. What do I care about? Mils and minutes. All I care about. Don't care about that. Don't care about that. Don't care about that. So 50 mils in 15 minutes. And I want to change those 15 minutes into an hour for my mils per hour. So what am I going to run that at? Do the math. Now, technically, if this hour was a clock, right, and I wanted 50 to go in 15 minutes, 50, 100, 150, 200, I would have to run it at 200 an hour. Not that they're going to get 200. Okay? I'm tricking the pump so that instead of like the last antibiotic, it went in a half hour, it's now going in a quarter of an hour. So that means technically I'd be able to hang 4 of those, 1, 2, 3, 4, in that hour. So I'm just tricking the pump. You know what the pump does? The pump goes, runs faster to get it in on time. Versus a regular IV. A regular IV would be like, for 1 drop. This is making the pump go. The pump is turning faster to get the fluid out faster. Okay, so then we move on to IV flow rate problems. So in this, there are 2 equations. Okay? Now remember, and don't be confused because these are going in per hour, okay, and mils. So this is going in per hour, not per minute. Okay? So a pump is hanging here, and we want to get this fluid in how many hours? Okay? So if something is running 125 per hour, if it is running 125 mils an hour, okay, just consider this like miles per hour when you're driving, okay? Just consider that every hour you could drive 125 miles, okay? We're going to get to this in just a minute, but this would be like a liter of fluid. 1 liter equals 1,000 milliliters, okay? So if this bag was running at 125 an hour, how many hours would it take to have that bag disappear? How do I know that? How do I figure that out, right? So what you do is say, if I want to drive 1,000 miles and I'm going at 125 miles per hour, can't I divide 1,000 by 125? If I divide 1,000 by 125, it's going to tell me that there's enough fluid in here for 8 hours. Okay? So, think about this. Okay? Say, I want to get somewhere that's 1,000 miles away, and I only have 8 hours to get there. If that's true, I would need to drive at 125 miles per hour to get there in time. Okay? So this would be considered total volume. This would be considered the time. And this is considered the flow rate, the rate at which I must drive, or the rate at how much per hour the pump needs to run to get this bag empty. Okay? The caveat being that if it comes up to be 125.8, I cannot see a partial drop. I cannot set my pump to 125.8 on a med-surg unit. It's going to be whole numbers. The same way that with this tubing, you will be increasing and decreasing the flow rate on this little device so that the drips drip in this drip chamber faster or slower. So in the same thing, I can't see 3.4 drops per minute. Okay? So this is with a pump, mils per hour, because my pump goes in hours. If I don't have a pump, like during COVID, I am going to pull tubing, and every package is going to have a different number here. Okay, so I want to check what my tubing package number is, because this tells me there's 10 drops for every mil of fluid. If there's 10 drops for every mil of fluid, that's how I know what I need for this. Okay? So when it's going to go by gravity, you want to know the drops per mil so that you can adjust it to how many drops per minute you're seeing in this drip chamber. So if the answer were 8, think about it. If it's 8 drops per minute, you literally take your stopwatch, your watch is behind this little chamber, and you are watching how many drops of fluid are coming out per minute. If it were 8 drops per minute, I ain't got time to stand there for 8 minutes to figure out if I've got this set right or not. So what I would do is take that 8 and divide it by 4 and get 2 drops every 15 seconds. That would give me a lot faster to get back out of the room. Okay? But at the end of the day, the answer will be in drops per minute, so that while you're in the room and you've got a minute, you watch it and you make sure that it is going correctly. Okay? So if you're in a room and you see drip, 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 drip in the drip chamber, you know that it's going pretty quick. If you only see drip, drip the whole minute that you're in the room, it's going really, really slow. Okay? Now, this number can be a 10, a 15, a 20, or a 60. So it's important to pay attention to what the drip factor is of the tubing that you are being given to use. All right, let's go look at what that looks like on a test question. So, here we go. First one, the doctor orders a 500 milliliter bolus in 4 hours. How many mils per hour does it need to run at? So I come right over here and I say, oh yeah, volume over time. Volume over time. My volume over my time, if I have to drive 500 miles in 4 hours, how fast do I need to drive to get there? Leave that in hours because we're on a pump. 500 divided by 4 is 125 an hour. Now, if I was driving, I'm probably going to get picked up by the police. Okay. Next one. My IV is running at 80 mils per hour. It's asking me at 80 mils per hour, how much total volume would I put in my I&O for intake? Remember this? So instead of giving me the total volume this time, like that 500 up there, it's asking me for the total volume. Okay? So I could put 80 plus 80 plus 80 plus 80 plus 80 plus 80 for 6 times. Or I can do the math and realize that I'm going to put 480 mils of fluid in this patient's body. Now, taking that another step, if there are half-liter and liter bags, which one am I going to go pull out of the back? Half-liter is 500. A liter is 1,000. That is an IV bolus. I'm going to go ahead and run to the back, grab that 500 mil bag, and set that pump at 80 mils per hour for the next 6 hours. Okay? I can do these problems again and again and again, just changing the amount of fluid and the hours, and get a totally different problem every time. See what I'm saying? All right, let's try 2 more. So this one is a little more complicated because it's asking me a 2-stepper. No worries. I'm just doing my thing. So I read it and it says it's running at 100 an hour for 6 hours. Okay, 100 times 6 equals 600. Then it says, then was decreased to 25 an hour for the rest of the 8-hour shift. How many hours do I have left? I would have 2 remaining hours of my shift, and it's going to be running at 25. So that is 50 mils. That means at the end of my shift, I'm going to go ahead and put on my I&O table 650 in. All right. I'm going to erase just so that we have some extra room here, okay? So this says 1,000 bag is hung at 8 o'clock, and it's running at 75 an hour, at 75. At 2 p.m., the doctor asks to give the rest of the bag over 3 hours. Oh, hold on. Shoot. So at 8 a.m., it's running at 75 an hour, and then at 2 o'clock, he tells me. So how many hours was it running at 75? 9, 10, 11, 12, 1, 2. So 6 hours of time it's been running at 75 an hour. So don't I want to find out what's in the bag right now? So I would go ahead and take my 75 times my 6 hours. It's 450. So I'm going to take 450 away from 1,000, and I've got 550 left in the bag right now at 2 o'clock. Now the doctor says, give the rest of the bag over 3 hours. Take that and divide it into 3. 550 divided into 3. And I need that baby to be running at 183 an hour to get rid of the rest of that bag. Okay. You can watch this over and over and over again. All right, so that first one, I was running a 500 ml bolus in 4 hours. So I just want to go ahead and take my 500 and divide it by 4, and it's running at 125 an hour. Can I double check myself by saying, wait, hold on, 125 times 4 should also equal 500. So double check yourself before you hit submit. Two was an IV running at 80 mils per hour. What's the total volume in 6 hours? 80 mils per hour. That's a times sign. 480. Can I also say if I wanted 480 to go in 6 hours, it would need to be running at 80 an hour? So I'm double checking myself here. Fabulous. And then this one in review, I'm running 100 an hour times 6 hours, 600, plus for the next 2 hours of my 8-hour shift, there's 2 hours left. He wants that to run at 25. So 600 plus 25 plus 25 equals 650. I've double checked myself and I'm correct. This one's a multi-step. I just have to think about it. I hung 1,000 at 8 a.m. It's running away at 75 an hour, and I'm writing in my chart 75, 75, 75, 75, 75, 75. And then the doctor asked me, hey, you know, he don't look so good. Can you just run the rest of that bag here over the next 3 hours? I said, certainly, sir. And I pull the bag, and I see that there's 550 in it, and he wants it to go in the next 3 hours. Then I'm going to need to increase the pump from 75 mils per hour to 183 mils per hour. Okay. All right, so now comes these drip factor things, okay? Now the drip factor thing, I know that it's a drip factor thing and it's going by gravity because it's in drops per minute. So with that being said, I look for my drops, I look for my volume, and I look for my time. And that's all I care about. I don't care what's in the bag. So when I set this up, remember, my 10 drops go over here. My volume of fluid goes over here. And to make it easier, since I need this in drops per minute, if I don't do this now, I'm going to have to times it all by 60 again, okay? So if I could just say 4 times 60. So I convert my minutes right here, okay? I want my minutes down here. So if I convert that, yeehaw, okay? All I'm doing is putting my volume over here and my time by my 60 here and converting that already into my minutes and then timesing the whole thing by my drips. I cannot go wrong. Okay? If I just keep doing this the same way every time, I cannot go wrong. What does that equal? 250 divided by 240 times 10. Remember, I cannot see a partial drop. That 250 and 240 are close enough for government that it's about a mil a minute, and a mil equaled 10 drops. So I'm correct at 10 drops a minute. Okay, let's do a little challenger. So this is just an I&O. I&O. So I just look for what I need. Just looking for my mills around here. Okay, so over here, I'm going to say 150. So this IV is running at 150 for the past 9 hours. Cefazolin 100 doesn't tell me how many times that is, so I'm assuming it's 1. Two units of packed red blood cells, 275 plus 250. Packed red blood cells, based on the processing, may not be the same amount of fluid in each. So really be careful when you have packed red blood cells. It's not like a half a liter that's the same all the time, okay? 50 bolus for each one of those bloods. What else do I got here? Oh yeah, one of those. And 50. So when I add this all up, let's go ahead on my calculator. 150 times 9 plus 100 plus 275 plus 250 plus 250 plus 250 plus 50, 25, 25. So here's this. Here's this. Here's this blood. Two of these. And one of those. Don't care what's in it, only care how much. Holy cow, this guy better be peeing, because I put a bunch of fluid in him. All right, what about if I were doing an enteral feeding? Remember your peg tube? Same thing. It's fluid going through a pump, right? Don't care. All I have to remember is mils per hour. What are they asking me? They're asking me to get rid of 840 in the next 24 hours. 840 divided by 24 hours. That baby's going to be running at 35 mils per hour. I have a question. Can't I also then take 35 and times it by 24 and make sure that I have the same answer? It'd be the smart thing to do. All right, I'm going to leave you some problems. You can go ahead and pause the recording right now. Work on these problems. So these are your drip rates, okay? So just whatever they give you, right? Whatever they give you does not matter. Over 2 hours, 500 mils with a drop factor of this. Set it up the same way, change those hours on the bottom to minutes. So I got 500. How many minutes? 60 and 60, 120. Make sure you do the math right, or it won't come out. Okay. 1 liter, 10 hours with a drip factor of 10. 1 liter over 10 hours, 10 times 60. Set it up every time. You will not get in trouble. Now listen to this one, right? If it already gives you mils per hour, just go ahead and take it. Okay? Look at this. Isn't it the same thing as saying 1 liter over 10 hours? It would be running at 100 an hour. If I'm running it at 100 an hour, 100 an hour, think about it. That's 100 an hour, isn't it? Times my 10. Isn't it? Okay? So think about this, 100 an hour with 15 drop factor. Okay? Do the math. And now you've got this little thingy this little thingy, this little thingy, oh, this little thingy, this little thingy. Now this is a little tricky because it's giving you extra stuff you don't care about, okay? Just consider it that the doctor ordered it as 1 liter of fluid to be given over 8 hours with a drop factor of 20, okay? So here is a question. Why do I care about the liter? Why do I care about 8 hours? It's asking me, after 3 hours, the nurse finds 300 remaining to be infused. Oh, hold on. 300 in the remaining 8 hours? So it was written for 8 hours, but after 3 hours, oh my gosh, a whole bunch went in. So wait, I want to slow that sucker down. So 5 hours would be 300. 300 minutes. 300 mils, right? Isn't that saying the same thing? But I'm going over 20 drops per minute. 20 drops per minute. 300 mils in the remaining time. The remaining time is 5 hours. It's going to end up being 20. But anyway, this one, 1,000 over 8 hours. 8 times 60, 480, right? Do the math, and then times that by 20. That'll set it up for you. There you go. I hope you have fun with these. I love these problems because they really get you thinking. This is something that we teach you in nursing school, and you think you're never going to use it again, but you really, really will when a worldwide pandemic comes through. Or you think, why do I need a pump? This is easy. I can just do this. My caveat to you is what's in the fluid makes a difference. We'll talk to you later.